we look at the solutions to problem set 18 here, which is on probability. We have a bag with 5 balls, numbered 1 to 5, each ball being unique. What is the probability that we pick 4 followed by 2 if we keep the ball out of the bag once we have picked it? Well, the first ball can be any one of 5. So we have a 1 in 5 chance of picking a 4. For the second ball, we only have 4 balls left. So the probability that we get a 2 is 1 in 4. So the probability that we pick a 4 followed by a 2 is 1/5 multiplied by 1/4, which is equal to 1/20 or 0.05. Otherwise, there are 20 possible outcomes, since there are 5 possible from the first ball and 4 from the second, and the probability of any of them occurring is 1 in 20. Get the same result either way. Next, we have a bag with 6 balls, numbered 1 to 6. What is the probability that we draw the balls 2 and 4 if we pick 2 balls? Here we're picking 2 balls from 6, and we don't care about the order. So we could pick 2, then 4, or pick 4 and then 2. So we use 6 choose 2, which is 6 times 5 divided by 2, which is equal to 15, and the probability is 1 in 15. Otherwise, we have that the probability that we pick 2 and then 4 is 1/6 multiplied by 1/5, which is equal to 1/30, using the same logic as question 1. To pick the balls 2 and 4, we could pick 2 followed by 4, or pick 4 followed by 2. And so we add the probabilities to get 1/30 plus 1/30, which is equal to 1/15. Again, getting the same answer 2 different ways. What if we put the ball back after picking it in question 1? Here there are 25 possible outcomes, since there are still 5 balls when we pick the second time. So the probability of getting 4 followed by 2 becomes 1 over 25, which is equal to 0.04. So remember, in question 1, we kept the ball out of the bag after we picked it. So the second time, there are only 4 possible balls to pick from. While if you put the ball back again, when we're picking the second ball, there are 5 possible outcomes. That's why we get a different answer. Evaluate 8 exclamation mark and 4 exclamation mark, as I put it in the problem set. Well, the operation is called factorial, so we normally say evaluate 8 factorial and 4 factorial. And that means 8 factorial is 1 multiplied by 2 multiplied by 3 multiplied by 4 and so on up to 8, which is equal to 40,320. And again, you can put that into Google. If you just type in 8 factorial, it works it out. Likewise, 4 factorial is 1 times 2 times 3 times 4, which is equal to 24. Evaluate 9 choose 5? Well, 9 choose 5 is 9 times 8 times 7 times 6 times 5 on the top, divided by 5 factorial. Work that out and you get 126. Normally, you'd have the brackets with 9 on top and 5 below. I've just written 9 choose 5 instead here. We pick 2 cards from a pack. What is the probability we end up with a pair? I didn't know what the answer to this one was when I put down the question, but I thought it should be doable. Well, when we pick the first card, we want the second card to be the same type. So, if you pick a 2, I need the second card to be a 2 in order to get a pair. So once we've picked the first card, there are only 3 cards out of the remaining 51 which would lead to a pair. So the probability that we'd end up with a pair is 3 over 51. Also, I forgot the main thing last week when I was asking about, is the Euro Million or the Lotto a fair game? Well, mathematically, as far as when we talk about fair game, a fair game means that on average you get your money back. So the expectation value is the amount you bet. That's not the case with Euro Million, since a lot of money goes back to charity, the government in taxes and so on, with the rest given back as prizes. So it's not a fair game. In general, you end up with less money. Now, given that we know that this is the case, what I talked about last week was, is it fair in that it actually does what it says on the tin? That it follows the rules, which is not what we mean when we talk about fair games from an expectation value standpoint. We'll look at this Euro Million again when we do statistics. Remember to subscribe to be updated when new content is added. Thanks.